Scientific argumentation. What is it?
It's true. No, it isn't. Yes, it is. Amy told me, so it's true.
No, that's just an argument. Scientific arguments have lots of important parts. Claim. A statement. Explanation of a claim. Evidence and reasoning. Level of certainty. Explanation of certainty level. Limitations of the evidence or reasoning. Okay, we can see you are uncertain about this entire process. That's okay, you'll get it by the end. Scientists start with making a claim. Claim. Brown-eye parents can have blue-eye children. Here's another claim. Earthquakes are more likely to appear along fault lines. These are all scientific claims that can be backed by evidence, collected by observation, or experimentation.
I have a claim. Chocolate ice cream is much better than vanilla. No way! Vanilla is the best.
I like strawberry.
Seriously? Actually, I don't like ice cream at all.
Are these scientific claims? Can they be backed by evidence? No, these are opinions. Okay, let's think about evidence first. What is evidence? Evidence is data. Data comes from observations you can make in the real world. Or in a model. That's where reasoning comes in. Reasoning is explaining why evidence matters. Reasoning explains how your evidence supports the claim. Let's use a real example. Let's say you're planning to take a trip to New York City next week. You are looking forward to walking around the city and seeing the sights. Oh no, it looks like there is a hurricane forming off the coast of Florida. Yep, looks like Uncle Joe is going to get soaked. Will your trip to New York be rained out too? Let's examine the evidence. What data do we have? Here's the storm forecast. What is this map telling us? First, this map is a model that shows the projected movement of the storm. Is the hurricane going to hit New York? If so, when?
Looks like it'll hit Friday. It could hit Virginia instead.
Yes, the model shows a range of times and places when and where the hurricane may hit. Good thinking. We cannot be 100% sure where it will hit or when. The storm is moving north, but its exact path is uncertain, especially the farther into the future you try to predict. Notice that the cone gets wider. This is the cone of uncertainty. 1-day forecast is very certain. 3-day forecast is somewhat certain. The 5-day forecast is even harder to be certain about. Scientists are most confident in their predictions when they have a lot of data. This computer model is based on lots of data like temperature, wind, barometric pressure, observations, and historical data from past hurricanes. Back to our map. We see that the storm will move up the coast and may arrive in New York City on Thursday or Friday. What scientific sources affect your certainty? Yes, there is a possibility that the storm will slow down and hit on Saturday.
The speed of the storm could change.
Indeed. The hurricane may change its path and bounce off into the ocean. Righto, we will be more certain when we get closer to the weekend. So, what did we learn? Scientific arguments start with a claim. Claim a hurricane will hit New York City before Saturday. Then there is an explanation of the claim, which includes evidence and reasoning. Explanation. The model shows that New York City is within the forecast path of the storm. If the storm continues on the forecast path, then it could hit New York City by Saturday. The level of certainty is 80%. Finally, there is an explanation of certainty. Looking at the map based on the cone, the storm should hit New York City earlier than my trip, but the storm could slow down or change its path. We hope you enjoyed the show.